So good morning, everyone. Welcome to the second session this morning, Gaining Real-Time Intelligence. Understand your threat environment through the enterprise immune system. So just some housekeeping again. Just remember your mobile phones. And also, if you've got questions for our presenters, you can submit them via the app. Or if you prefer the analog way, we'll just stick your hand up and we'll bring a microphone around to you. So your presenter today is Sanjay Aurora from Darktrace. Sanjay has had over 25 years of experience in the enterprise software industry, specializing in the Asia-Pacific region, where he's held a number of senior roles at leading software companies, including Interwoven, Oracle, Autonomy, and OpenText. Sanjay is responsible for leading the expansion of Darktrace and its award-winning enterprise immune system in the exciting Asia-Pacific region. Sanjay will be joined by Peter Hewitt, the country manager for Australia. So please make them welcome.
Thank you very much. Quick sound check. Heard loud and clear at the back? Perfect. So thanks for the introduction. The next 30-odd minutes that we have, we'll do three things. I'm going to be talking about a fairly unique new approach to cyber defense. We call it the enterprise immune system. Peter will then join me to do a demonstration of this technology, and then we'll take Q&A, which I think should last about 5 to 10 minutes. So that's the plan for the next 40 minutes. Thank you very much for your participation. Very quickly, to get into this presentation, I use this image. And this is the image which I want you to keep. There is no big story here. The image is, if you look at civilizations, countries, societies, companies, and the way we could protect them, the way they worked was this way, which is build a wall. They were fairly simple ways to protect, basically by saying, build a strong perimeter, check everybody who's coming in and out, and we can secure civilizations, societies, countries, cities, as well as organizations. The second image you want to keep in mind when we talk about the enterprise immune system and why we need to look differently is this. This is how new cities, this is how new companies, this is how you and I live, operate, work today. The challenge, and this has been a fairly big challenge in the cyber defense or cyber security landscape, is we are still trying to put the resources, still trying to believe that we can protect a company, a city, a society like this using walls, using perimeter. And I think that is the fundamental issue. If you, and you are the experts in this field, but that is the fundamental issue. How much time, money, resources, technology we still spend thinking we can prevent from bad actors coming inside. We can still say, I will build a bigger firewall, I will build a taller wall. The reality is, this is how we work. And that's why there is such a huge gap around legacy approach to cyber defense and what we read in the newspapers. So just keep these two images in mind as I introduced the next few topics around enterprise immune system. So given the first two slides, there was a group of people, mathematicians in Cambridge University, very passionate about machine learning and unsupervised machine learning, and experts from government intelligence agencies such as MI5 and GCHQ who have seen cyber threats, that are very real. They have protected national infrastructure, they have protected London during Olympics. Those kind of people combined their topics together. They had a coffee, and that's where Darktrace started. It's a Cambridge University offshoot, funded by Invoke Capital, which is a London-based VC company. But the fundamental of these two people coming together say, we need to find a new way to solve this challenge. In 3 years, as you can see, and I'm not going to hop on every topic, in just 3 years, Darktrace has 1,000 deployments. It's a global company. We have 20 offices. We have customers and offices in Australia and New Zealand. It's been accepted as one of the game changers. You look at the awards, not only do we have awards from Gartner and InfoSec as the best security vendor, my favorite here that I pick always is the World Economic Forum. This is called the Technology Pioneer Award. This doesn't go to cybersecurity firms. This doesn't go to IT companies. This goes to anybody who's a game changer. People like Airbnb, people like Dropbox, people like Google have received this award. So bear in mind that when I'm talking about our success, it is being recognized as a new approach, a new way of thinking, which has been materialized into the enterprise immune system. A quick look at these customers we have. We have large customers across all industries, across all geographies. You will see these slides everywhere from every presenter, so I won't kind of spend a lot of time, but a lot of customer validation is a proof point in just 3 years that we've had 1,000 deployments. Not reading the bios, but there are 3 kinds of people that made Darktrace successful. First is people like Jack Stockdale, who's our CTO. When I say people like Jack Stockdale, our Cambridge University offshoot R&D center is filled with people like Jack, who are really passionate about how does math and machine learning work to solve problems. The other kind of people that made Darktrace very special and successful is people like Dave Palmer. Dave Palmer, who's ex-GCHQ, and his bunch of colleagues who provided the domain knowledge, who provide the expertise around why and how these things emerge. What are the patterns these cyber threat actors use? So it's not just a classic software startup company coming out of California or someplace. It's a very seriously thought through company where people like Jack, people like Dave Palmer have set together how to solve this problem. And finally, people like Nicole and myself who have the experience of running software companies, making them global, expanding into different geographies, and making sure that we are able to deliver customer service like a world-class software company does. On the right, you will see some heavyweight names. Lord Jonathan Evans, former DG of MI5, 33 years of government intelligence expert. He is one of the board advisor. He adds a lot of weight around what we should do and what direction we should take. Dr. Mike Lynch, Alan Wade, et cetera. So fairly influential people in this space. So the first few principles that we started this company was these. First, if you still think that you can fully secure your network, it's not going to happen. So it's just not possible to fully secure any network. That is, it is better to assume that rather than say, because I've invested in technology and people, I can sleep well. That's the fundamental principle we take. The second is this, which is I think the visual is very clear, and that we read in newspapers every day. If all the organizations that we read about, and the last one I think today is the Apple something happened, yesterday was LinkedIn, they've invested in everything. But the fact is, when sophisticated attackers decide to come, they will come. The taller walls you build, the taller ladders they'll get. Third, and I think this has gained a lot more momentum and realization that it is not just about the perimeter. The battle at the border is frankly over. You will still have to do what you are doing, but the real battle is inside your network, to have the visibility of what's going on. Whether there is an insider who's doing malicious stuff for commercial advantage, or whether it's a naive insider who just still clicks on links, who still does those things that you as security professionals have told them 1,000 times, please don't do it. And the last thing, of course, is rules and signatures. Again, important, but it's always a catch-up. You can never be up to date throughout the organization. So these were the 4 things we wrote down when Darktrace was founded 3 years ago. Now, this is the slide where if I do a good job, you will extract a lot more meaning from this presentation. This is obviously DNA. And if I can just quickly check, anybody wants to talk about which animal has the strongest immune system? Any names? Anyone? It's the crocodile. Sorry? It's the crocodile. Crocodile's immune system is the strongest. And you know the conditions they live, the way they fight, the swarms, the blood. So they need really a very, very strong immune system. The second is human. The human immune system is the second. And this is a picture of a DNA. Why am I showing this picture is if you look at our human body, if you look at the way we are attacked by unknown bacteria, unknown viruses all the time, and just imagine our organization and our human body to be similar. How does the human race thrive, survive? How do we interact with us? Because of the immune system. What does the immune system do? The immune system is a self-learning capability that understands me. My immune system understands Sanjay. Peter's immune system understands Peter. If there is something that doesn't belong to me, comes to me, either my skin, which is my perimeter defense first is my skin, it'll fight. If something evades, something more sophisticated comes in, either my DNA fights or alerts. That is largely the principle of an enterprise immune system using math and machine learning. So what the enterprise immune system tries to deliver is using sophisticated unsupervised machine learning. It understands how your organization, how your networks, how your devices, how your users work and behave. It understands what is normal for your organization. What is the pattern of life for this company? Because when a sophisticated attacker is doing the recons, when the sophisticated attacker, which has evaded those usual approaches that you've put in, we are assuming that something will evade. Now that thing, when it is moving, it will cause a behavior which is not normal. And that is detected in those early stages, not in later stages when it is almost becoming headlines. So that is the fundamental approach of enterprise immune system. As I mentioned earlier, it is 100% based on unsupervised machine learning. It learns what's normal. It establishes a pattern of life. Any subtle change, anything which is not normal, using advanced math, I keep repeating that because that is the secret sauce of our approach and the success we've had. We use clever mathematics to able to correlate using Bayesian math, weak indicators. If this is happening to this device, and by the way, is this happening there, and the time is so and so, and the connectivity is there, actually this means this. To be able to extract meaning out of a lot of information is what Darktrace does. You get a visualizer, which Peter, my colleague, will show you in a minute, how you investigate threats. That's a very unique way of getting a total inside-out visibility. It's a 3D intuitive, fairly advanced visibility. You are able to play back for the last 6 months what's going to happen or what happened, so you can do forensics, you can do detailed investigation. But the key here is it is learning in a real-time manner. It is detecting threats which are either insider or outsider based on behavior. No rules, no assumptions, no signatures. Very proud to show this slide because, as I said, we are from Cambridge University. This is Reverend Thomas Bayes. Obviously, he did a lot of research around Bayesian theory, which is all about probabilistic mathematics. It's about understanding from weak indicators what is the meaning, what is the probability of this sequence of events being that. That is what the core of our technology is. Again, no prior assumptions are to be made. The appliance comes into an organization, whether it is a hospital or a city council or a bank. You don't do any rules, you don't do any signatures, you don't anything. It learns automatically. It uses Bayesian math to then correlate and give you the alerts real time in advance. So the way it works is it's an appliance. It installs in an hour. Within a couple of weeks, it establishes what we call a pattern of life. It continues to evolve, it continues to learn, and as more traffic comes in, it basically is spanning traffic. So it's not inline, it's passive, and then you start getting alerts around what happened here, why it is this way, and you are able to investigate further to really go to the root cause. So this device or this technology is not your usual firefighting, is not your usual, hey, these 29 things are coming in, I found that. You'll get that. You have other devices. What this does is those very sophisticated attackers who are hiding, who are evading, who are successfully in your network without your other system being able to catch, this thing goes after that. So that's why it's a very important complementary solution to your existing technology stack. The existing technology stack, I'm sure you're very familiar with this. On the left side is prevent. Pretty much the firewalls, the next generation firewalls, the signatures, the sandboxing, essentially everything that you can do to prevent from bad guys to come inside is in the prevent category. And on the right category is the respond, the react, hey, I got hit, call 1-800-HELP category. Again, these two categories have been fairly well established and understood. There are many players, and I'm sure you have the right amount of investment in this. The category that is becoming a largely growing very rapidly and becoming very important is threat detection. Is assume something or the other will breach, but they spend about 200 days inside your network before becoming or before being able to do something serious. In those 200 days, when they are making those lateral movements, which other systems are not looking for, because most of your systems, most of your people, most of your technology is still looking outside. When they are moving inside, this is the category, we call it the enterprise immune system, but essentially this category is becoming more and more important because you have enough time to detect those before these things cause damage. So that's the category that we play in. I think I'm doing okay on time. Architecture-wise, we sit next to your core switch. We span the traffic. We consume traffic. The more traffic the appliance gets, the more it learns. The more it learns, the more wiser it gets. The more wiser it gets, the more subtle changes it detects. So that's where we sit in. We add, as we call, dimensions to the traffic we listen, and we model. We model every user mathematically, every user, every device, every part of the network. Once again, there is no customization, no configuration, not a single line to be added to the device. It learns automatically, starts to cluster information. How do salespeople work? How do these set of devices work? How do HR people work? So it does on its own, learns, again, what we call pattern of life. And from that, it does a very interesting mathematical modeling, which is threat classifier. This is to reduce the number of false alerts. Actually, we don't even call it them false alerts. This is the Bayesian math that comes into play, which is once you've understood the traffic, once you have modeled the devices, users, and behavior, and then you start to look the mathematics of it. If this is happening right now, can I also look at the other people, or can I look at the other parts of the network, what is happening there? And that's why the threats we provide have gone through this threat classifier layer, if you may, and the number of threats you receive are very small, but the interesting events, they are all about unusual events, interesting events that are worthy of further investigation. So that's how it works. It's, again, not a typical firefighting tool. One of our very large installations at BT is a global customer and a partner, they get about 12 to 15 alerts a day. That's it. And those alerts are sophisticated in nature. So again, this is more towards those sophisticated attacks and sophisticated alerts. And the threat visualizer, you're going to see it in a minute, so I won't speak about it. That's something which you will definitely like. A couple of case studies before I hand over to Peter for a demonstration. Drax is one of my favorite. And the reason is Drax produces energy for Europe. About 12% of energy in Europe is produced by Drax. Why is it important? Is Drax realized early that they need to protect their corporate networks like all of us do. They deployed our technology. They were very impressed with the fact that the machine could learn what is normal for Drax corporate network. They then came back to us and said, we have more trouble or more sensitivity towards the operation side, where the industrial control systems are. Can you use the same technology, Mr. Darktrace, to model the behavior of my industrial control system environment? So our product, which is called the Enterprise Immune System, working with Drax, was developed for industrial control systems, and we call it the Industrial Immune System. After Drax, there are several energy companies, even in this region, who have adopted our technology, because now you have a helicopter view of not only your corporate network, but also of anything that is going on in the industrial side. So special interfaces were developed, and that's why I'm saying this is my favorite, because our product is co-developed with guidance from Drax. Another one which is quite interesting to me is Virgin Trains. Virgin Trains, as you would have heard and experienced, very high on customer experience. You know, these trains have all Wi-Fi. They don't want customers to feel anything less than they are free to do anything. The coffee machines talk to the train servers where they can decide what coffee, what sugar, what low-fat milk is needed, all kinds of fancy stuff. But their security team is obviously very worried, because if people with such an open network with fancy things, how can people be secure of the hackers not making advantage and doing something nasty to the other mission critical parts of their network? So when they adopted us, and they call us a game changer again, because now they have the visibility of everything that is going on in the network, which they never had. And I'm repeating, they have the visibility of everything that is going on in the network. Forget for a minute malware, forget for a minute the usual cyber stuff that we talk about. This is the first time Virgin Trains is able to see their network transparently 24/7 real time. That's why they love us so much. So I have pretty much come to the conclusion of my slide. Just to conclude, the enterprise immune system, largely built around human immune system, but by using mathematics and machine learning, is unique. It's new, it's rapidly getting adopted, it is complementary to your stack of solutions. You don't have to replace things. It is a thing that adds to what you are currently doing. It installs very quickly. It's powered by math and machine learning. And basically what we do is we engage with our customers to say, because math, machine learning, Bayesian, after a while it gets like, where is this going, right? What do we really do? So what we offer to organizations is a proof of value. We bring the appliance to you. The appliance sits in for a week. It learns your pattern of life. And for the next 3 weeks, we'll give you reports. We'll give you 3 reports of what the appliance found interesting happening in your network. You can see your network. You can see your inventory of the devices, of the subnets, and of some of the vulnerabilities that come in. So the proof of value is offered just to make sure that you understand how the machine learning is applicable to your organization. So if anybody is interested, Peter and I will be at our booth later. We'll be happy to engage on that. With this, thank you very much for your attention, and I'll turn it over to Peter now.
Thanks. Mic check, you can hear me. Okay, we've got a bit of a video, so I'm going to talk to the video. I'll just check that that works. And I'm going to try and pause and replay occasionally. So this is the visualizer. So Sanjay talked about our detection capability. A key part of the Darktrace solution is also the investigative capability, and it's where all of the experience of our MI5 founders comes from. They've spent their life in a cyber intelligence world investigating threats. And this tool is designed from the ground up to provide you with an investigative capability on your enterprise network. And it's typically a capability, and it gives a visibility into your network that people just simply don't have. When we put the POV in for 3 weeks, one of the things that happens with the network administrators is they don't want to give it back, because it shows them, it allows them to investigate and see what's going on in their LAN in a way they've never been able to do it before. So this is basically the screen. The system just builds out an understanding of the network from scratch without any human intervention. It's quite clever. We're currently, on this particular example, spanning 2,000 subnets, 38,000 devices. In the bottom left there, we've got the threat tray. This is where the anomalies appear. So the mathematical anomalies, the system will just show you those, and they appear in the threat tray. Top left-hand corner, full elastic search, and a bit of a time machine in the top right-hand corner, where you can go back in time to a specific point on a network, look at a device, a subnet, and actually play back the network traffic and watch what's going on. And then it allows you to see things in a way you typically can't see them. Each of the sites is a different colour, and the colours are important. Red is very, very bad, very high confidence threat. Blue is pretty cool and normal. And we'll just zoom into the UK there, if I can press the button. So each of the blocks you see on screen there is a subnet, and the yellow one is the net where there's an outstanding alert. So the first thing we see is a live 3D representation of that particular subnet. The blocks at the back are the subnets that subnet is talking to, and each of the dots there on screen is a machine. So we work out the operating system, the machine names all automatically. We can click on a machine, and then we drill down into that device. We can actually see what's going on. Open up the device event log, press play, and we're now watching the live network traffic on that particular subnet, and we're watching it on screen in text on the left and visually in the centre. Now, it looks quite nice. That's what happens when you put a bunch of MI5 cyber intelligence people in a room with a couple of game developers. You end up with an interface that looks like this. So it is quite useful as well. One of the things we've found, our cyber analysts who do this investigative work all day for our customers, they find this visual representation quite powerful, because if you're trying to track down a strange problem, it's quite useful to put the subnet on screen and just have a look at what's going on. See if you can spot any unusual connections or links or thick lines. And that can sometimes lead you down an interesting path. On the left, at the same time, we see all the network traffic related to that specific device we've got selected in the middle. And on the right here, we've got basically the metrics we're tracking for that machine. So we can visually and graphically see internal packet history. So what are the trends in data transfer, internal data transfer, external data transfer, number of connections, connection durations. And again, it's all about allowing you to look at lots of different aspects of a device once you see an anomaly related to it and work out what's going on. On the bottom section there, all these things are the models that have triggered for that particular device. So all the models that have breached their thresholds. And again, you can go and dive in and have a look at those models, change them, modify them, raise the sensitivity, lower the sensitivity. But the secret sauce is really how they're combined mathematically to determine the anomalies. And some of them are very straightforward models. So if we just, if we click on data transfer, we can see the data transfer history for this particular device. Okay, So we go back to the land view. We can also go and have a look outside the perimeter. So if we're seeing a particular amount of traffic going out through the perimeter, we can dive out to the world and we can zoom out and go and have a look at some of the devices that are out there in the world where we've been connecting from that particular subnet. Yeah. And dive back into the LAN. So one of the things I wanted to be able to try and do is to move forward a little bit. I'm not sure how I'm going to be able to do that. All right, so what we've got here is an investigation. So we've got an anomaly triggered in the bottom tray there. You can see on the left, the breach log is showing that we've got a connection, I can't read that from here, with unusual activity with a very high probability. So we can open up the breach event log, and what we see is the network transactions that are relevant to that model breach. And we can go and bring that up graphically. We can actually see the trend. In this case, we've got, I think, a large data transfer. And we can actually see the history of that particular data transfer. Again, visual, quite useful. This particular one, we've got another model breach, unusual activity strength 67%. Open up the breach event log. And what I've got there, and this is the interesting thing, so I've got three things that have contributed to this particular breach. So it's unusual activity 67% due to internal data transfer, internally connected devices, and internal connections to closed ports. Now, it's not that there's any rules in the product that say those are evil. One of the things we don't do is build a lot of rules about what normal networks look like, because it doesn't work. Everybody's network is different, and it's actually one of the reasons why we work so well in industrial control environments, because they're very different networks. But for Darktrace, it doesn't matter too much. Most of our modelling is done at a fairly high level based on header information. So we don't really do analysis of the data in the network transactions at all. And in this case, what we've got is we've got three things that have contributed, and the breach log is showing us all the network transactions that relate to that. And what you can see, if you look there, is you can see a whole bunch of failed connection attempts to machines on the same subnet within a couple of IP addresses of our desktop in the middle there. The yellow desktop is where the anomaly is detected. What we've actually got going on here is an APT that's poking around the network looking for credentials. And what follows is a file transfer that's unusual and some connections to ports that are unusual. Now, it's not that any of those things are evil, it's just that the combination of those three is very unusual for this machine. And the truth is, when an APT is on your network, or whether an employee is doing something they shouldn't be doing, or where just a piece of malware has got past and you're not detecting it because the AV's broken, all you know is symptoms. And the idea of this tool is exactly that. Once you see the anomaly, you can go and investigate it and work out what's going on. So what would we do? And I'm nearly done with the demo. So we can actually go and have a look at this and say, right, well, let's have a look at the actual attack. As I hover over each of those threats, you can see the graph changing on the right-hand side. So it just gives you the internal connections, data transfers in context, so you can see how it's different. So let's go back 1 minute to before the breach, press play, close the breach event log, and open up the device event log. And what we can actually watch is the network transactions leading up to that. So we'll actually see each of that summary of network transactions in amongst the network traffic and where the breach is fired. So again, quite a powerful investigative tool to understand what's going on. So obviously, if you're in the middle of doing this investigation, trying to work out what's going on, just a quick word on Sue Smith. Did I stop that? There's no active directory lookup. We're obviously a passive device on a span port or a tap on the network. But we see the original authentication request and we track those transactions. So we can work out after the fact, if we need to, whose credentials we used. And we do create and we model credential behaviour continuously. So we're keeping a track of those models. So one of the things you might want to do at this point, and Sue's in HR, so we might want to understand at the end of this breach there was a file transfer. What was the file transfer about? Was it related to Sue's job? Was it a legitimate HR process, or is it something different? So we can go and highlight by application protocol. There's a lot of different ways to filter the data in this view. And we can go and have a look at the different file transfers that have happened around and related to the breach. And we can actually go and grab that file transfer. Because one of the things we do as part of the span process is we keep the first 10 or 20K of every file we see in transit. We keep them for about 3 weeks, a 3-week rolling window. We're not trying to be a forensic copy of your network, but it just makes it much easier to create a packet capture as part of your investigation. So if you want to see what's going on, you can actually just go and do that, create a packet capture. And I think it's still on the screen there, but you'll see about halfway down the screen, you'll see that there's access to a file that starts with MA, merger and acquisition requirements and pricing, 10th of July 2014.doc. Probably not a file that Sue should be accessing. So we might go and have a look in that file, and that's what we've just done. You'll see a little green pop-ups happened on the bottom left-hand corner there. So we said to the system, give me a packet capture of the file that was transferred. open up the packet capture, and we've got a rudimentary Wireshark-like device capability. We call it Darkshark internally, just to allow you to go and have a look what was in that file transfer. So that's kind of it. I've got in that video is just another few demos of different types of threats. Really, I hope what I've demonstrated is the capability. One of the things we find people, they feel this is a little bit like a seam. It's trying to give you the capability of a seam. We don't replace seams, but we're very complementary to them. And one of the things it does allow you to do is investigate network traffic very, very rapidly. You know, if we push all of the network traffic to the appliance, to the Darktrace appliance, you've got it there for history. Getting it to log files and into a seam environment to do a query of things like, you know, one of the things network administrators ask me is, can I get a list of all the new MAC addresses on my network in the last 10 minutes, or the last week, or the last hour? Yeah, easy. It's just a query in the search. Can I look at all people who've accessed a particular URL via a browser in HTTP? Yeah, it's easy. Just type it in. It'll be back. You know, you'll have the results in seconds. And that sort of thing is very, very difficult with a seam, and it takes minutes or hours. So quite a powerful investigative and visibility tool. Look, if you've got any more questions, please come and see us this afternoon or tomorrow. We'll be there. And that's pretty much us. Done.
Thanks. We have about 5 minutes. If there are any questions, we'll be happy. So, Darktrace.
Yeah.
We assume that the environment is infected already.
Yep.
So if you're doing mathematical modeling around
Yep.
an environment that's already infected,
Yep. Which is common.
you're ingesting traffic or data that's already infected and you're creating a model
Yep.
of infected traffic.
Yep.
So how do you then determine what's infected and what's not?
So it's not single dimensional. So what we do is we're building models for all of the different devices on the network. And the system is very intelligent in that it compares them. So it looks at every laptop in the context of the machines around it and the wider enterprise.
Right.
So if the whole network was infected with Conficker, every single machine, then yeah, we'd have a huge problem because it would look normal. But it's actually very good at spotting existing undetected malware infections in the first couple of weeks, because it builds a model of all the laptops, and then the one that's actually infected is different, and it spots that almost straight away, actually, usually in the first 7 days.
Yeah.
It's quite clever.
Good question.
Yeah, it's a good question,
Yeah.
actually, a very good question. Any other questions? Don't ask me about the maths, because we've got some paperwork that explains the mathematics, but I'm no mathematician. Yo.
I'm wondering about the API service that we are good.
Yep.
As part of the first diagram of the architecture, there was some mention of an API to
Yep.
interact.
Yes.
So how that works? And
Yeah, sure. So the product, just about everybody who puts it in integrates it with their SIEM or their SOC environment.
Right.
So there's two things. We can export the alerts via email. We can do email alerting, or we can export them via syslog or JSON format. Most of the SIEMs, Splunk, Logarithm, Sumo Logic, ArcSight will all absorb that format quite readily. So you can see the alerts in your SIEM if you've got an existing SOC environment. If you want to go a bit further than that, there's a full web API. So from another environment like your SIEM or something you built yourself, you can actually query the device itself and ask it a myriad of things. You can ask it about alerts, you can do queries about machine details, what models have fired on a particular IP address or MAC address. It's quite rich. So there's a full web API if you want to do that sort of integration. It's quite straightforward. We can give you details on that if you'd like some more. Just grab us at the stand.
Thanks, Peter.
No worries. No, not yet. We're a bit too young. We've only really been in Australia for sort of just under 12 months. I don't think so, no. It's a bit of a unique capability. I mean, we really don't compete or replace any of the existing technologies. It's kind of it's a new capability. As I keep saying, that the visualizer is quite pretty to look at, but once you start using it, it's unbelievably powerful. The search is quite cool. The things you can find going on in your LAN are really quite astounding. And what we do is we give people a 3-week proof of value. We just give them appliance for 3 weeks. And one of the challenges with new technologies is getting to know how they work. And we try to solve that by, we put it in for a week, we let it do its modeling. And one of our cyber analysts, they're all ex-MI5 or MI5 trained guys, and they connect to that same interface you saw. They look at the anomalies, they do the investigative work, and they write up a thing called a threat intelligence report. So the idea is that you don't have to learn how to drive it to understand the value. We get those anomalies, we detail them in full detail, what we did, the investigative steps, what we recommend, and then we sit with you and we review it and we show you how we did it in the visualizer. It's just a much quicker way to see the value. And we always find interesting things when we put it into customer networks. Often it's internal network administrators doing things they shouldn't be doing. We find a lot of employee behaviour, people running whole of VPN. There's still a significant amount of people who've got staff downloading BitTorrent movies, and they are sure it's blocked. They say they can't be, it's blocked at the firewall. These technologies are designed to get around your firewall. They're quite good at it. But whole of VPN is rampant, and those of their ilk. We often find employees just hacking other people's desktops for fun. We spot that quite often. We had one customer in Singapore, actually, a big energy company. And one of the things we found during the POV was it was 9 o'clock at night, we found an inbound connection from their external, their Citrix ICA gateway, internet-facing device, to a desktop, and then back to their other Citrix ICA gateway. And that was obviously odd, because it had never happened on that device before. It was a couple of different things, and there was some significant traffic for an hour. So we raised that up, and we had that in the threat intelligence report. And Gabriel, who was the IT administrator, the director of IT for APAC, I showed it to him, and he said, oh, that was me. I was at home and the ICA gateway wasn't working and I couldn't get to it. I could get to one of them, but we blocked RDP in the DMZ, so I couldn't hop across to the other one, so I had to bounce via my desktop. And I said, okay, well, that's good to know. And he said, but the fact that you detect that gives me great confidence that it will actually be able to show us things that are going on. And we found a stack of other really interesting stuff on the network. And they're a customer now, they're really happy with it. They've got 8 appliances all over the planet, 8 sites. Any other questions? Sorry, I'm talking. I should be listening and waiting for questions. No? Okay, thanks.
Thank you very much.